Once we have an understanding of the radian measure of an angle, we can take advantage of that to help us calculate the length of an arc, meaning a part of the circumference of a circle, if we know the angle associated with that arc. And then we can also use it to find the area of a sector, meaning a part of a circle, again, as long as we know the measure of the angle associated with that sector. Now, for the formula for the arc length, this is just a rearrangement of our definition of radian measure. If you'll recall, that was theta equals the arc length, S, divided by the radius, R. So if I just multiply both sides by R, I isolate the arc length. And so that's what we have here. So the key is that theta that we're going to use to make this calculation for the arc length has to be measured in radians. If we're given that measure in degrees, we have to convert it to radians for this formula for arc length to apply. And the same is true for the sector equation. So for the sector equation, we have area equals 1/2 times the radius squared times theta. And so again, theta has to be measured in radians for us to be able to use that formula. So right away we can see in the example that the angle is given to us in degrees. So before we can use the arc length formula of S equals R theta, or the area formula of 1/2 R squared times theta, we have to know what that angle measure is in radians. So we're going to have to use the conversion factor to convert it into radians from degrees. So our conversion factor, as we know, is pi radians over 180 degrees. So if we do our reducing cross canceling, the degrees go, so that leaves us with radians as our units. We'll go ahead and leave our answer in terms of pi here. And so then we just have to reduce 180 and 35. And so if we divide by 5 on the top and bottom, we get 27. And then here we get 36. And then, of course, we can see that we can reduce one more time. Both the top and bottom are divisible by 3. So we get 9 and 12. One more time, divide by 3, we get 3 and 4. So the end result is 3 times pi over 4. So the radian measure equivalent to 135 degrees is 3 pi over 4. So now I'm ready to jump to my arc length and area equations. And again, we'll leave our answer in terms of pi in both these cases. So my radius is 12 times 3 pi over 4, my radian measure. So if I do a little cross-canceling reducing, I've got 1 and 3. So if I multiply 3 times 3 pi, I get 9 pi. And this would be a length measurement. So this would be in inches or feet, or since we don't have a label, we'll just put units, just so that we remember that it is a length. And then for the area measurement, we've got 1/2 times our radius is 12, so 12 squared times our angle in radians, so 3 pi over 4. And so I've got 1/2 times 12 times 12 times that 3 pi over 4. So I'm going to do a bunch of reducing here. I've got the 2 and this 12 gives me 6. The 4 and the 12 gives me 3. So in the end I have 6 times 3 times 3 times pi. And so our end result here is going to be 54 pi. And now since this is an area, it's not going to be in units like the arc length was. It's going to be in units squared. So if it was inches for the radius, it'd be inches squared. If it was feet for the radius, it'd be feet squared, and so on. So area, unit squared, but for the arc length, which is a length, it's going to be in units.